Yo guys, we are back and today we're going to build a wallet tracker. And the idea was originally to put this in a 5 series or a 5-part series, but I think I will be okay with 2 videos on this topic. In today's video we will check how we can pull the transfers or the signatures from the transfers from these wallets. Then based on these signatures, check what the transfers actually are, and if they are token transfers, then we will take the token information like metadata and we will store them in our local database. And that's how we will track when a wallet sells or buys. And in the second video we will go into more detail on the wallets itself. We will try to make a leaderboard on which wallet is actually doing best and their current P&L. So eventually I want to build this into a Discord bot. So if you're not in Discord yet, you should join for sure. I will put the link in the description. But if you can see, we already have a token hunter bot here. And I will try to do the same with this wallet bot where we can actually add wallets from all our Discord users and then see when a new buy or sell comes in. And we can also have a leaderboard of the wallets that our users have provided. So that's the idea behind this wallet tracker, wallet bot. But for today, we're going to just see how we can track the wallets and how we can get the token information for the tokens that the wallets actually buy. Again, if you're not in Discord yet and you want to see how this project unfolds, the link will be in the description and I hope to see you there. Alright, before we jump into the code base, I want to give you a quick overview on how this wallet tracker will work. So we will have our config file and there we will store all our wallet addresses, and also we will give each wallet like a name. So then we will have a function that will run every second, and that function will go through all these wallets that we provided. And for each wallet, it will use the Solana Web3 GS package to make a call via the Helios RPC to the blockchain. And the method that we will use is the get signatures for address, and we just need the public key for these wallets. So if we have done this request, we will get back the signatures that are associated to a certain wallet. So we will get back all the signatures that this wallet has actually participated in. Now, once we have these signatures, then we want to check if they're actually good. So what we will do first is export all the signatures that have no errors, because we don't want to have bad signatures. We just want to have signatures that have actually a valid state or are actually errorless. So once we have all these signatures, then we will parse it into the Helios Enhanced Transaction API, and there we can actually process batch. So we will give more signatures or more than one signatures based on how much we get back here. We will send them to the Helios API and we will get back the actual transactions associated with these signatures. Once we have these transactions, we can see if they have token transfers, because a lot of these transactions, they will not be token swaps, they will just be something else. So we will export the token transfers, token swaps from these transactions that we got back. If we find these token swaps, we will store them in our local database because we want to keep track of them. And if it's the first run, then we will just output like, hey, we found so much token swaps for this wallet. And in the next video, we can then calculate the P&L and do the leaderboard. But if it's not the first run, then we will go on, because in the first run we will get a lot of transactions in, and we don't want to just process them. We just want to make sure that we covered these transactions. So if it's not the first run, that means that new buys and sells can come in. So what we will do then, if we have a valid buy and sell, we will use the Helios DAS API, or it's like a standard API to get the metadata from a token. And here we will use the get asset request to then get back the actual metadata from the token that has been bought or sold. And again, this we will also store in our local database. So if we have this data, then we just output it in the console and we say that this token has bought or sold that this wallet has bought or sold a certain token. So that's the whole workflow, and I will try to come back to this overview once we are in the code base to actually see where we are at and at what stage of the tracking we are. So that's the whole overview of the tracker, and with that said, let's jump into the code. Alright, before we look at the function itself, I will show you what I will build. And you can start it by typing npm run start tracker. And this will start the tracker, connect these connect to the Solana blockchain, as you can see, and then it will pull in all these transfers for the two wallets that I have specified in the config file here. So first wallet has 34 transfers and the other one has 14. And now this script is constantly listening for transactions that are being done for any of these wallets. So if you would, for example, go to GMGN and I would say I want to buy this token here with for a really small amount, and I do buy, and I just enter my password here, confirm, then we can go back because it's successfully bought, and then eventually it should pop in here. There's a slight delay of a few seconds, of course, but if all goes good, it should pop up in here that we bought this token. So here you can see wallet 1 bought the doc we've had for like 0.01 Sol. I can also click on this link that will bring me back to the actual token, and then we are here, and we can also do a sell 100%. There we go, confirm. So now we sold this token, and if you go back to the script, then it should also come in here like in a few seconds. So there we are, and you can see that wallet 1 sold doc we've had for like 0.009, so a bit of a loss there, but yeah, that's fine. It's just for the purpose of the demo, and you can also click on it. But in this case, you can see that the token buys something, sold something, that it's like mutable, that it's burnt or not. And we can also see the wallets up on top here. And in the next video, we will of course look at the P&L and the actual leaderboard to see which wallet does the best. So for now, it pulls in the transfers by the first run, and after the first run, it will monitor the wallets to see what they buy and what they sell. So that's what we will build. Alright, here we are. So once we type that start command in npm start tracker run, then it will start the index file and it will start main. So this functionality, after it initialized the connection. An initialized connection is just using the Helios RPC URL to then make a connection using the Solana Web3.js package to the actual Solana blockchain. And we verify that by looking at the connection, and if we get back a version. And if we get back a version, then we know that we are actually connected and that we can use this connection to perform like requests. So once that has been done and there is no error, then it will trigger main, and that's what we do here. So main is setting a transfer limit for 5 in this case, which is set in the config file, and the config file is located here. And the transfer limit is just how much transfers we will pull in at a time. So we set it at 5, but if it's the first time that we run this script, we will set it at 30. And it just means that we will look at the 30 last transactions that this wallet has done. Once we go on, we have the transfer logs that we just specify here to put our logs in, so we can store our logs and output them later. And then we will pull in all our wallets. And the wallets, again, they are stored in the config file. And if you look here, that's where I specified the wallets. So you have wallet 1 and wallet 2. And these are just public keys for any wallet out there. So that's what we do here. Wallet count is just for the future to build on top of for the actual leaderboard. But for now, it's just a loop, and it will count up 1, 2 to display the amount of wallets. So then for each wallet, we will take the wallet address and the wallet name. And that's actually just this, the name and the wallet address. And we will loop through it. So first thing we will do is save this wallet to our logs, because we want to output that we are tracking this wallet. And that's what you saw in the demo, the actual wallet name, the P&L for now. And yeah, like a small trophy icon if it's number 1, but the leaderboard we will do later. And then we wallet count, we add 1, so the next wallet will have number 2. Next, what we will do is check all the token transfers associated to this wallet. And what we do is we use this connection that we initialized earlier. We take the wallet address, so the key of the wallet, and the transfer limit. So if it's the first time we run it, we take 30. If it's the second time or more times, we take 5. And for this, we have a separate function. And if we look at that, Here we will specify some endpoints that we will use further in the script. But what we do first is actually take the public key from this wallet address. And for that, we also use the Solana Web3.js package, where we can just take the public key from that wallet address that we provide. And then we will use the get signatures for address method. And remember, this is an RPC method, but we're using the Solana Web3 SDK. So we can just use this connection to actually use this function here to get all these signatures related to this wallet. And again, this SDK just covers all these Solana RPCs. So you can also just connect to this using the RPC endpoints. And to show you what I mean, I have a Postman set up here. And the thing that we will use is this function here, get signatures for address. And it just uses the endpoint here. And here we give a wallet address. And if I click send, then it will get back all the signatures, as you can see, related to this wallet. And the body that we specified here, if you look, we set the limit to 1000 and in our script we had 30. But here we get back all the signatures related to this wallet. So that's what we are doing here. We're using the get signatures for address. And again, you can use the Solana method through a API call. But in this case, we're using the SDK from Solana Web3.js to do the same actual thing. And you can set the commitment to confirmed or finalized. And also this will contribute to the speed that it comes in. So if we receive no signatures, then we cancel out. We don't do anything. If we received the signatures, I can show you where we're at. We go back to the Drawio board here. So that's what we did here. We have the wallet. We use this package, Solana Web3.js. We use this get signature for address with the public key. We connect it over the RPC and we get back the signatures. So that's what we have received now, these signatures. And now we need to check if they have any errors or not. And that's what we would do here. We just go through all the signatures and we filter out everything that has an error. So that's what this line does. So we will only get back the signatures with no error. And here you can see error, null. So most of the time it's null, but if it would be not null, then we don't want to deal with it and we move on. So the next thing what we do is we take all these valid signatures and we send it to the Helios transaction API. And for this, we could also use the get parsed transactions from the Solana Web3.js SDK. But I choose to use the Solana, the Helios endpoint, and it's this one, the parse transactions, because we can also provide batch. And what I mean with batch is that, so query, you can send, let me look here, up to 100 transactions at a time. You can do the same with the SDK. There is also get transactions method. But I like this because it also filters out a lot of rubbish and we get it back in a readable format as well. So I think this is a really nice endpoint from Helios and I like to use it. It parses transaction based on a signature or signatures. And I also have it in Postman here so I can show you what it will return. It's the enhanced transaction API and here I provided 2 signatures or transactions. And if you send it, and that's what we get back. We have 2 replies. And the first one is containing a token transfer, as you can see here, with Sol. And if we look at the second one, we will see that it doesn't contain any token transfers. And that's what we are actually doing here in the next step. So we get back these transactions. And if it has token transfers, then we actually want these transactions. And again, you can see it here. That's the thing that we are looking for, token transfers. This one doesn't have it. This one does. So that's a valid candidate. And this is the information that we will need to process the actual buy and sell, because you can see here the amount of Sol, the amount of the token and the amount of Sol, and also the account and the token address, etc. So that's what we are looking for here. So only token transfers we are interested in. So once we get that back, we check if we actually received something. And again, here we also look if we got token transfers back. If we don't get token transfers back, then we filter it out. So we only get the transactions that include token transfers. The other ones we throw out. And then we move on. And here we have our logic that we check all the token transfers that we received. And we will pull out all this information like the signature, the fee payer, the timestamp, the mint of the swap. So the sol mint, the mint of the token. So all this information we extract. And then based on what the sol mint is, we know what the token mint is and what not. We take all this information, and that's just the information that I mentioned here. So we will take the sol amount, the amount of the token. We know what the mint is for the token. We know what the mint is for sol. And based on the from user account, if that is the wallet, we know also if it's a buy or a sell. So that's what we do here. So we store that information in an array. And I'll show you what I mean. So if the from user account is the actual wallet address, then we know that the token has been bought by the wallet. And if not, then we know that the wallet sold the token. So then we put all this information for this transaction in that array here. That's also the array that we will return back to our script. All right, so now we received all the transfers for this wallet that we are looking at. So we gave it a wallet address. We asked how much transfers we want back, and we got back the actual transfers for this wallet. So this function just went and checked the transactions that were related to this wallet. And based on these transactions, there was logic to filter out error ones and filter out all the ones that don't have token transfers. And if it has token transfers, it puts it in an array, collects everything and send it back to us to move on here. So this is what we received here. These are all the token transfers related for this wallet. So if we didn't receive anything, or that's possible, but if it was an error, then we will also console out the error. And if we didn't receive any new transfers, then we just continue, and continue means we're going to the next wallet. So if we received transfers, then we want to store them in our database. And for that, we have a separate function, and it's called insert transfer. And if you click on it, it goes to our database file here. And what it does, it just takes all these transfers, and it will use this functionality to store them in our transfers database. And what we do here is we open the database, and if it's not there, it will automatically create it. And we also check if the table that we want to store it in is actually created. And we have a function for that, create transfer table. And that's what it will do here. It will create a table, and if it exists, it will just return true. So that's what we do here. And if that is okay, then we set up a statement. We take our placeholders, and we store all the transfers that we have in the database. And we also check if there was a change count or not, and the last ID, so we know exactly if transfers were added or not. And the result is just queried here. Based on this statement that we run, we get a result back. And if the result contains changes, then we know that transfers were added, because that's really important for the next step. And then we return the change count, the last ID, and also if the store was successful. So that's what we do here. We just store these transfers that we received in our local database. And then we check if we have store count. Remember, we need to know if actually something was stored, if actually something was received, if we have new transfers, because this will also try to store the transfers that we had before, but the functionality is set up in a way that, and I can show you what I mean. SQL here. You need to insert it or ignore it. And this will for sure make sure that we don't insert transfers that are already there, because signature is a unique value. And if you go back to the table creation, you see signature needs to be unique. So this logic will take care of that. If we try to store a similar signature, it will ignore it. Otherwise, it will insert it. And that will also reflect in the changes count. So only if new signatures, new transfers are added, the change count will be increased. So that's what we do here again. So if we have new transfers that came in, because the change count is higher than 0, then we know we need to display something, because new transfers came in, and that means that something has been bought or sold by this wallet. So if it's the first run, then we just output how much transfers were added to our database. Remember, that's what we did in the demo. How much transfers has been added to your database. If it's not the first run, then we know that we received new transfers, and then we want to display it like, hey, this wallet bought or sold something. And since it's a new sell or buy, we also want to have the token metadata. And we are not in the first run, so we take the wallet address again that we are looking at, and the last created ID and the last amount of stored transfers. Remember, the stored count is what we got back here, and that's just the amount of records that we added. And we also got back the last ID. So we know the amount of records that have been added, and also the last ID from the last record. So with these two values, we actually know what transfers were just added. And that's what we use this functionality for. Get transfer details. So based on the wallet address, the amount of transfers that were added, and the last transfer ID, we can now take these transfers and we can look for their metadata. So what we do here is using this function, select token transfers by address. And what it will do is go to the database, and here it will look for these transfers for this wallet based on the limit. And remember, the limit is just the amount of transfers, the count that we got back earlier. And then we get these latest transfers. So if 2 transfers were added, then we get these transfers here. So we know that we have to go through transfers and get the metadata for these 2 transfers. So that's what we do here. Let's say, to recap, 2 new transfers were stored. So store count is bigger than 0. So we know that we need to take the token metadata for 2 transfers. And that's what we do here. So we take the store count and we add it to this function. So once we're at this function, we know we have 2 transfers that have been made, the count. Based on that count, we select the transfers from the database. Because remember, we can say this wallet address made new 2 transfers. So go and fetch these transfers for me. And that's what we do here. So once we get these back, we want to loop through these transfers because we need to take the metadata. So first thing we do is look in our database. Do we already have the metadata for this token? And we have a function for that. Again, goes to our database. And here we look in the tokens table. Do we already have metadata for this token? And if so, we return it. That's what we do here. If not, we can use a endpoint API call. And we use here for the DAS API and the get asset method. And I can show you what that means. I'll show you the documentation first. So you have the digital asset standard API. And if you want more information, what it is, it's a digital asset standard DAS API. It's an open source specification and system that provides a unified interface for digital assets. So it's a standard way of actually fetching data of the blockchain. But we are using the get asset method. I can show you what it does because also that I have in Postman. So here we provide the actual token. And if we send it, we get back the metadata, like the name, the symbol. And we also get back if it's burnt, or mutable. So that's the call that we do here. And remember, we only do this call if we don't have this token already in our database. So once we get this token back, or we have it in our database, then we store it in some variables like the meta name, the meta symbol, mutable or not. And then we store it in a object that we can then return or add to an array to later return to our function here. So that's what we do here. So we just get the token details for this transfer. And we need this token details metadata, so in our script, in our console log, we can actually show it nice. We don't just show the transfer ID or the token. We want to show like, hey, this wallet bought this token name, this symbol, so it's a bit more nice actually. So that's what we do here. We get these details back. And if we have the details, we do some logic here like, hey, was it a buy or a sell? Is it burned or not? Is it mutable? We store all this information in in variables. We also transfer the date stamps into a nice readable format. We create our inspect URL, and this URL is also creating config. So if you want to change it, you can just change this URL here and the name, and then you can make it how you want. And then we save this whole string with the time, buy or sell, wallet name, token burned, mutable, transferred sol, transfer token, all this information and the inspect URL we store in our logs. So then later we can log it out. That's what we do here. And we do that only if new transfers came in. So if we loop through all the wallets, we got all the information, all the signatures, all the transfers. We took the transfers that were new. We got the metadata from the tokens for the new transfers, and we did that for all the wallets. Then we move on and we output everything in our console. We clear it because we always want to show a clear picture of what's going on. We don't want to output everything underneath all the time. So if we clear the console, and then we just output our transaction logs or action logs and transfer logs. And that's what you saw in the demo. And if everything is done, we say that first run is now false, and we trigger the same logic all again in the specified amount of time. That's also in the config here. We say tracker timeout 1 second. So after 1 second, we will do this whole process again. And that's how the wallet tracker works at the moment. It pulls in all the information for the wallets every 1 second. Of course, there is a slight delay, but it gives a nice overview if tokens are being bought by the wallets that we track. And in the next video, we will improve on this script by adding a leaderboard, the P&L, and also notifications for these wallets once they buy the same token at the same time. So that's what we want to add to this script. But that's it for now. If you think this was interesting, leave a like, join Discord. If you have questions, you can put them in the comments, of course. But if you want faster answers, join our Discord. There's always people to help you. You can get the code there as well. I will put a link in the description. All the repositories for my code are in Discord. So if you join, you get access to the code as well. And with this said, I'll see you in the next one.